Hey, hello. How are you?
Good, how are you?
Hey, I'm good. I'm good. So can you share a little context, like which level you are applying for at Google,
Yeah, so
when is your interview?
actually, yeah, sure. So actually, my interview coming up in a few days,
Mm-hmm.
Monday, is
Oh,
actually for Uber,
okay.
and it's L5A. I am planning on interviewing with Google eventually, but right now
Okay.
seems like hiring is frozen. But yeah, for now, I want to focus on L5A at Uber.
So let me know if you need a reference at Google. Yeah. Um, sure.
Okay.
Awesome. So let's start with the question. Then, like, I will consider keep my question and my feedback around L5 at Google. Will that be
Mm-hmm.
okay? Yeah.
Yeah,
Cool.
yeah.
Awesome. So basically, like we will focus 45 minutes on actual system design, like you driving the discussion. Like I will keep 10-15 minutes for feedback.
Mm-hmm.
So yeah, do you have any drawing tool in mind which you want to use?
I've been using Excalibur.
Oh, nice. Yeah, cool. Can you share a link?
Yes, I will share a link right now. Here we go. Let me put it in the chat here.
Cool. Awesome.
Okay, so distributing 6 million burgers in 10 minutes. People will come and click on a button on app,
Mhm.
get my free burger. Now, once you get more than one burger, we should not promise more than 6 million people that they will get a free burger. Okay. Okay, so I think there's some clarification that I might need here.
Mhm.
Um, so let me just put on like a section called functional requirements,
Sure.
and uh, let me start clarifying here. So I guess there's an existing app, it seems like.
Yeah.
Um, okay, so there's some existing app of some kind
Mhm.
that will have some sort of promotion, like maybe is it like a screen that's going to pop up says like you can get a free burger if you click here?
Yeah.
Okay,
And
so
we'll focus on the backend. We don't need to worry about the app functionality. Like, yeah.
got it. Okay, um, no one should get more than one burger, so I'm assuming we're going to have some sort of identifier for the users. Is this going to be only for logged in users?
Yeah.
Okay, so only for users
Um,
with.
can you give me just one minute? Someone is opening
Sure,
the door.
sure.
Yeah.
Okay, are you back now?
Yeah, yeah, yeah.
Okay, so when you say
Are you
distributing six
typing
million,
somewhere?
no, no, oh, I was
Okay.
typing on the interviewing.io
Oh, okay, okay, okay.
first,
Sure.
just for the functional requirements. Then I'll go to
Mhm.
the Excalibur for the design. But so when you say 6 million burgers in 10 minutes, do you mean that people have only 10 minutes to claim meaning this whole promotion will be running for 10 minutes only?
Yes, that's correct.
Okay, so people will have 10 minutes to click on this. Okay, so no one should get more than one burger, and we should not promise more than 6 million that they will get a burger. Okay, so I'm
Right.
assuming that first we could kind of push this push the screen to the app or open this offer to initially 6 million people. But the question is, like, how do we
Um,
know?
no, it
Yep.
won't be like that. So, like, then we are expecting 20 million people to open an app and try to claim it. Yeah.
We are expecting how many million people? Sorry?
20 million people. We are expecting 20 million people to participate in this.
Oh,
20
I
million
see.
people would be like using the app to claim the burger. And
hmm
like we have to come up with some mechanism so that we don't promise more than 6 million people.
So, okay, so just let me understand. So, 20 million people will be getting the screen, but
Yeah.
once they click on
Oh,
get free.
screen is visible to everyone during
Uh-huh.
that time who has an account.
hmm
Yeah, so will be, but we are expecting like there are, let's say that there are 30 million people on the app, but we are expecting like 20 million to participate in this.
Okay, so this meaning so anybody that's over 6 million
Mm-hmm.
will say, okay, sorry, like all free
Yeah.
burgers have been claimed already.
Yes, yes, yes.
Okay. Over 6 million will get a sorry message. Okay. That seems okay. So that seems like, and am I assuming now all the user information and all that is that already existing, like all the account information?
Yeah, you don't need to worry about logging authentication, or you can assume whatever information you need to build this system exists in the user table, or you can also exist there is a user service which gives all the information.
Okay, got it. Um, right. So it seems like the non-functional requirements is built out from that. I guess my first question would be in terms of latency.
Hmm.
Um, when they click get my free burger,
Mm-hmm.
how fast are they gonna have to get like a response to say like, oh, you got the free burger or you didn't?
100 millisecond. Yeah, it's a
100 millisecond response uh, to see if they get burger. Okay. Um, all right. Now, in terms of, okay, we said that. So, in terms of, let me just think in terms of data storage. I guess, do we need to like store historically which users got burgers, or just like a count? Well, 1 second. So since we don't want anybody to get more than one burger, I think we have to store which users. Basically, we have to store 6 million records of like a user ID and just a user ID, really just a user ID. So like we need to store 6 million user IDs.
Mhm.
Um, Now, in terms of uh, how many requests we're going to get a second. Um, so can you tell me how many requests I get a second? I guess I can get an idea by
Yeah,
like 10 minutes, but
yeah,
uh,
yeah. So basically, we can assume like fairly distributed traffic over 10 minutes. So from 20 million, you can come up with some
right,
numbers.
right. So 20 million users uh, divided by 10 minutes, so that would make 2 million users a minute,
Mm-hmm.
and uh, divided by 60 would be 200,000 divided by 6 is like about 50 um, something like I don't know 35k
Mm-hmm.
requests per second about.
Mm-hmm.
Okay. All right. And which other non-functional requirements? Oh, is there any like infrastructure that's already existing that we could use, like maybe like distributed counters or anything like that?
You can assume that, but you can talk about like assumptions about expectations from that infrastructure.
Hmm. Okay. Um, Got it. All right.
Mm-hmm.
So I think that's kind of what we need for the non-functional requirements. Um, all right. So let me kind of move on to. It seems like the high level design, just in terms of like from a user perspective, is pretty simple. But let's design it anyway. So I'm shifting to Scala Draw now. So here we have. Oh, and another thing is, which I don't think will really affect the design, but what type of clients are we going to support? Is it like mobile and web?
Yeah, mobile and web. Yeah.
Okay. All right, mobile and web clients. All right. So here we have just the client, and I think the first step that we'll have is sort of an API gateway. Um, API gateway is going to take care of things like first of all, like just authentication, right? If the user has an account,
Mhm.
like authenticating the user, also like SSL termination, maybe rate limiting. It's like in case there's like a malicious user that wants to spam spam the service. So the API gateway will take care of all of that. Let's see, like authentication, rate limiting.
Um, so I'm just typing some feedback notes. Like, let me know if my keystroke are annoying you.
No, it's fine. I don't hear it.
Yeah,
That's
sure.
good. Okay. Um, all right. Now we have load balancing, and I'm gonna make a section here just for like come back later, things I want to discuss later.
Mhm.
So first thing is going to be like load balancer single point of failure. How we don't want to make the load balancer single point of failure.
Mhm.
But let's have here bunch of servers. So we'll have just like the API servers here
Mhm.
replicated.
Mhm.
Um, okay,
Mhm.
and and the API servers will talk to the service. So the actual this will be like a new service,
Mhm.
burger giveaway service. So let's have this.
Mhm.
Let's have that over here. Um, burger giveaway service. Okay. Um, Now, so obviously we need some sort of storage behind this. So the first thing we'll do is just have, ooh, what is going on here? I don't know how, okay. Um, let's have a database,
Mhm.
and we'll have to talk about what type of database and the schema. Uh, so DB, and let's put in the come back later to DB type and schema.
Mhm.
So now, I think the challenge is so okay. We're gonna have 35k requests per second.
Mhm.
So it seems like we're not gonna for every. It seems like this will be pretty write heavy,
Mhm.
because basically every request, unless like they already got a burger, but we're assuming most users are not gonna click more than once. So I think most users will just be like a write request. So it's going to be pretty write
Yeah.
heavy.
Just to
Yep.
correct you, like there could be multiple requests from single user, and
Hmm.
we should consider like not allowing that.
Right. Yeah. No. Yeah. We definitely have to consider not allowing it. I'm just thinking in terms of like read and write,
Mhm.
like ratio. So you're saying that it's possible that the read ratio that reads will be like significantly higher than writes because a lot of users are going to click more than once. Okay.
Yeah,
So
it depends on how you design it. Like, yeah, but I'm saying like a lot of user can re-click the claim, try to claim the burger multiple times.
right.
Like how you make sure take care of this will depicts like
Got it.
how many reads or writes are.
Right. I see. I see. Um, that makes sense. Um, okay, so it seems like this is a very important component of the system. So let's think about that right now. It would seem that like if we have like multiple write replicas, we would want there to be strong consistency, right? We want that we shouldn't have like one user writing to the database that they claimed the burger and then read from another database that doesn't say that they claimed the burger yet.
Mhm.
Um, so we want there to be uh, uh, consistency. Now, I guess the question is, what happens if there are concurrent requests
Mhm.
from one user, right? So a user clicks twice really quickly,
Mhm.
but um, they click twice really quickly before the first request has time to like execute and be written to the database. So I'm just thinking that it seems like that um, if we would have like a unique constraint on the database in terms of like
Mhm.
key, in terms of like user, we can sort of, as long as there's strong consistency,
Mhm.
I think we can take care of um, I think we can take care of like the double burger problem.
Mhm.
So like uh, so what happens? User writes to the database, and then um, if another kind of request that comes like right after, even after, even if they're concurrent, a SQL database that has acid properties
Mhm.
should not allow the second request to um, to finish
Mhm.
to execute successfully. So the second request will get sort of like an error response saying that it wasn't successful. So
Mhm.
only the first burger will be claimed. Okay, so that I think so. So I think it makes sense here since we need strong consistency. Even though it's write heavy, it's kind of write heavy. But I think a SQL system could um, handle 35K requests per second. And even if it can, we can always shard the database. But I
Mhm.
think it makes sense over here, since we need strong consistency, to use a relational database system, like something like
Mhm.
MySQL or Postgres. Um, okay.
Yeah.
Um, and I think pretty much the schema will just be um, I don't know that we need anything except for like just a user ID here, or maybe time, like user ID and then like
Mhm.
time of claim, maybe.
Mhm.
Um, that's pretty much it. Okay, now let's see which other issues we can run into um, that we would need to solve for. So the first thing is possibly sharding the database.
Mhm.
So that sharding would mean like we would just like hash by user ID, hash the user
Mhm.
ID, and route those requests um, to those instances. Um, and then another thing, if we end up sharding a database, like another thing we might want to discuss is like service discovery or something like
Mhm.
Zookeeper. Um, okay, now I guess another thing to make the system efficient. I guess let's see which other issues we have to handle. We have to handle, first of all, maybe adding a cache here to make reads a little bit more efficient. So
Mhm.
that would be one thing to discuss, and also another thing to discuss is like the counts. We want to know um, that we don't exceed 6 million burgers, right? So So here is where I guess where we could run into concurrency issues, right?
Mhm.
Because let's say, um, let's say we're at 5 million, right? 9999999, and
Mhm.
and two users tried to claim a burger. In that case, we might overcommit. Um, so, okay, so it would seem like a naive maybe approach to a naive approach to solve this would be to have a different record in a database, or maybe like a separate table or one instance that says how many burgers are left, right? How much inventory do we have? It starts at 6 million, and then as the count goes up, it goes down, and then we could, I guess, again, this is very naive, but a naive approach would be like to put a lock on this count, right? So that every user that clicks, we lock the count and we decrement it by 1. The reason why we need some sort of lock or some sort of concurrency management is because if two users try to decrement the count at the same time, we don't want it to be decremented just once. We want it to be decremented multiple times. So
right.
Okay, so that happens so that's the solution of putting a lock. The problem of a lock is obviously it's not going to sustain all this traffic, right? Because we have one record that's trying to be written to 35,000 times a second. So that's not gonna hold up. Okay,
Yeah,
so
that's a good point.
Yeah, so I think we have to look into some sort of replication here. Not replication, but actually like distribution of these counters. And then the question is how to aggregate them, right? Once we distribute them. So let's say we have a bunch. I'm trying to think of a solution to come up with over here. If we have maybe a bunch of counters, okay, but then the question is we need to sort of aggregate all the counts, right? So one solution we can have is have distributed counters, and that we have some sort of just round robin load balancer that writes every request to a different instance, and we can have versioning or even we could even have locks really on these counters, since if we have enough instances, the lock is hopefully not going to take too much time. Or there's another approach of having a version on the counter, so to make sure that every write is actually an increment. So
nice.
So that would be one thing. That would be one way to do it. But the question is, we need to aggregate these counts. Now, that's not a problem to actually aggregate the counts. We can have a process doing that. We can have a worker that kind of just queries every counter and then resets, counts total amounts of counts for each instance, resets it and then and goes on. The only problem is, how do we do it in a way that doesn't exceed, that we make sure that we don't exceed 6 million, since we're distributed here, right? Okay, so we have to think of a strategy for doing that. Okay, so we have distributed counters, and we have a process that kind of aggregates them. And we need to make sure that we don't exceed 6 million. So I'm just wondering if we can somehow write to each counter, what's the total left? After each aggregation, we say, this is.
So, sorry, I got confused, a little confused. So now you're talking about having distributed counters, right?
Right. Let me add that actually to the system so that
that would help me to understand. Yeah, thank you.
Yeah, sure. So Burger Giveaway Service is going to talk to the database and a cache. It's also going to have I don't know what kind of box to make for distributed counters, but distributed counters, and we're going to have Okay, and we're going to have a process here, workers, like aggregating workers, like aggregators. Okay. And these aggregators are gonna. So what are the aggregators gonna do? They will just write to a separate, just a very simple table. You know, that's probably separate from the main database that holds the users, because that one is going to be distributed. This one is going to be like a very simple, just one record. So like it's going to be like a database with total table. Total table. Okay, sorry about that. So this is like a total. The aggregator is going to write to the total table. So this is my model currently. This is the design currently. So we have distributed counters and we have an aggregator. I guess the problem I'm trying to solve right now is, even after we have the aggregator, we don't want to find out after the fact that we're above 6 million, right? So let's say like the total.
Sorry, like few like logistic questions, like where these distributed counters are, and is your burger giver service is a cluster of servers, right?
Yes,
And
definitely.
okay,
It's
and
replicated.
and where these distributed counters are saved?
Okay, so these distributed counters would be like, and it would be probably like a in-memory counter, like maybe something like Redis or something like that. It's like a cluster, and I guess we can have like a load balancing level, a load balancing tier that distributes them evenly, or maybe we even have. Well, I think it's even possible to have, to be honest, to make it quicker, have it. Okay, so the problem is, like, I guess a simple approach would be to have each burger giveaway service instance to just save it in memory. But the problem is we want some sort of persistent layer, right? We don't want to we don't want to lose counts, right? So that's why I'm thinking to actually have it as a separate, like maybe Redis tier that that also has like it's in memory, but it has a persistent storage as a backup, right? That's what I'm thinking. To have like Redis with persistent layer. No, that's for persistent layer. There we go. So will just be a cluster of Redis servers. Does that make sense?
Yeah, I understand the problem. So basically, you're saying like if you had these counters in memory on the burger giver service,
right?
What was the con in that? Like
the con of it. Yeah, no, the pro is that that'll be really fast, right? It doesn't have to talk to an external service. The con is that if an instance goes down, we lose the count.
Makes sense. Yeah, I totally relate to that.
I'm just thinking, but like, what would be are we gonna be able to like maybe just do a count just on the database itself, right? So what happens if we can do a count? So do we need distributed counters, or maybe we can, like, on this main database here, I'm wondering if we can just keep doing like an aggregator that goes over all the instances of these databases and does a count vir. So do we actually need the distributed counters? That's my question.
So like yeah, that is okay. One another thing, like what is the role of total thing, like count? Where you would use the total thing, like this aggregator and then this total thing, where you are using it?
You mean where we're reading from it, right? You mean where we're reading from the total?
Okay. Sorry, I did not understand. So can you help me with the so burger request comes to giver service. So distributed counters are like your incremental counter or decremental counters?
We can do it as incremental counters, right?
Okay, so they
Increments, and then
increment.
it's resets as the aggregator aggregates it, like resets every time it's aggregated.
Oh, okay. But then again, you need some coordination between these distributed counters and aggregators and total count, right?
Right, exactly. So then I hear it right. That is true. But either way, we need some sort of coordination, right?
What if
Because
like you have decremental counter?
I'm sorry, which counter?
If you have decrementing counters, like let's say if you have 10,
Oh,
let's say if you have like six distributed counters, they will initially be 1 million each.
oh, I see. Okay, yeah, that's a good point. Oh, that's a good point. So if we have decrementing counters,
Mm-hmm.
um, the benefit of that is that once a counter is finished, we won't use that one anymore.
Mm-hmm.
Um, but we can still go to a different counter and check,
Mm-hmm.
does any other counter have capacity still? And since we'll have like a load balancer, or it'll come with maybe the Redis cluster will give us like for free like an even distribution, we can assume that it's not going to be like one counter finishes much quicker than the other. Okay, yeah, that is a good point. Okay, yes, that is a good point. So in that case, we don't need the aggregator, and we don't need the total table, right? All we need is distributed counters, and then let's just write here incrementing. So basically, we start with as many divided by, as many 6 million divided by as many instances as we want to have, and yeah, okay. So yeah, so we could again, so we can use the same schema as before, as using like versioning or a lock on these counters to make sure that each one is actually decremented. Okay, awesome,
Mm-hmm.
cool. And yes, I think that takes care of the counter problem.
Mm. Okay. And
I
like where you would save what is being stored in DB? Is this DB?
Okay, so yeah, in this DB right here,
Mm-hmm.
um, we're first of all we're going to add a cache, but we're just going to store just the specific users that already claimed a burger. So and we'll have basically before um, okay, so we'll have a cache. Trying to figure out how it would work out with the cache, because we need to write to the cache as well if we're reading
Mm-hmm.
from the cache. So let me try to figure out what the order of operations is. So the burger
Mm-hmm.
giveaway service, first thing we have to do is, I guess, write to the
How
counter.
like
Yeah,
do you
sorry,
need
go ahead.
cache and DB both for saving 6 million user IDs?
Um, do we need a cache? I mean,
Can you
I guess
estimate the storage for 6 million user IDs?
yeah, 6 million user IDs would be able to fit on one instance for sure.
Mm-hmm.
But the question is to speed up the reads. But
Mm-hmm.
I guess you're right that we don't know.
No, I'm just
Yeah,
asking.
I
Like,
think you're right.
I
I'll tell
don't.
you what. No, I'll tell you what. No, I'll tell you why I'm going to reconsider the cache right now,
Mm-hmm.
because generally you'll use your cache when you
Mm-hmm.
have some data that you know is going to be, more frequently accessed than others, right?
Right.
In this case, we don't know which data will
Mm-hmm.
be more frequently accessed. We don't know if there's going to be a specific user that's going to just keep on trying or whatever. So we don't necessarily,
Right.
and even if like one does, even if like one keeps on trying, it doesn't mean that
Mm-hmm.
they'll still keep on trying, in 10 minutes. Maybe it'll be a different user that will keep on trying,
Mm-hmm.
right? So I think that's why it makes sense maybe not to have a cache. And I
Mm-hmm.
guess it's okay if like subsequent. I guess it's a little more acceptable if like the
And your
first.
all entire data can sit in memory, right? So technically, it would be an in-memory database, not a cache, because like 6 million could be.
Right, 6 million could very easily fit in memory. So I guess we can have a Redis layer for this as
Hmm.
well. Redis backed by persistent as for
Hmm.
both of these, right? So like we
Hmm.
have Redis backed by persistent
Hmm.
um, for both of these components. That's a good point. Um, um, yes. Okay. So then,
So yeah, so let's go back to the flow again.
right. So let me go back
Um,
to the flow. So yeah, go ahead.
yeah. So basically, what kind of load balancer you are having? Like between the API servers, uh, it's a round robin, right?
Between the API service and the Burger giveaway service, yeah, we'll have a round robin
Mm-hmm.
load balancer.
Okay.
Just
And like
simple.
this distributed counters would be on some um like extra component in memory counters, and which counter to use is like how well you know like which counter to use from burger
Um,
giveaway service.
yeah, I'm not familiar with exactly with the different products, but I think what we
Mm-hmm.
would need is an in-memory counter that has a persistent layer as well.
Mm-hmm. Mm-hmm.
Anything that, right, and probably just like a
Yeah,
key value store, right?
let's assume that there exists something. But like which counter any particular request goes to, how will you that determine? How will you determine that thing? From burger giver service to counter, which counter you would be
I don't think
using?
it really matters. I think we can use a
Okay,
round robin
so you would have
schema over
additional
there
load
also.
balancer in between.
Well, I'm assuming that the database itself kind of can take care of that, like the database
Okay.
service. Like once you spin up a cluster, like
Mhm.
it'll take care of like the load balancing. It'll take care of. I think there are. I'm pretty sure that there are products out there that
Mhm.
will, that you just spin up a cluster and it'll
Mhm.
take care of like routing each request to like a separate instance based
Let's
on
say
like it.
let's say you don't have any such thing,
Right.
and you how would you do that?
So then you would need some sort of like service discovery just to tell you which instances are available, and you
Mhm.
would use a round robin scheme
Okay.
to so like you would have um, so you would have like a right you would have like Zookeeper
Okay. Got
sit
it.
over here. Um,
Cool. Yeah. Let's not complicate this design. Yeah. Fine. I understand. Like somehow it works. So yeah. So just like help me like with the flow from any particular request when it comes to burger giveaway service. What is the first step? Whether adding an entry in DB is the first step, or decrementing counter is a
Yes,
first
I
step.
think the first step is going to be to decrement the counter because we need to know
Okay.
if we have capacity available, right? So
Mhm.
we search
Mhm.
for a instance that
Mhm.
actually has capacity available. Okay,
Mhm.
so I see what your question is actually a pretty good one because we also need to have some logic that so maybe we can have this actually on the client on the kind of on the server level. I have some logic that says try an instance. If the
Mhm.
count is zero, try a different instance, right? Try any other
Mhm.
instance randomly, and or not well not randomly. Well, maybe we can have some sort of service that I don't know if there's something that exists, but I'm just thinking that like we have
How
like
about like simple caching, like a simple hashing on user ID, and then like
a
based
simple
on
what?
hashing on a user ID, and based on hash going to one of the counters.
Um, I don't know if that would work because what happens if one counter kind of runs out of capacity, but there's still capacity
Hmm.
left on other counters.
Yeah, good point. Yeah,
So that's why I'm
interesting.
thinking we have maybe some sort of service discovery service that in addition to having a health check, right? It has a health
Hmm.
check, but in addition to having a health check, it also checks like what the current count is. And if the current count is zero, it just brings it offline, or it just deregisters that service. So
Hmm.
now, uh, when we query Zookeeper again,
Hmm.
um, we only have the instances that are currently still have capacity left,
Hmm.
right? So that would help us like, route. Yeah, we would have to have some sort of logic on the request that
Hmm.
says like if it's zero, retry a different server, and if we can't find any that has capacity left, then just like fail the request.
Hmm.
We're gonna have to have that logic. But once we get a successful read from the distributed counter, meaning we found one that still has capacity available, that's when um, oh, I see what you're saying. That's when we write to the database. But I guess we also have to check the database before, right? We
Hmm.
have to check to see if this user already, before we actually decrement the counter, we have to check that this user didn't get a burger yet. So it seems like maybe we would have to have some sort of like status. I think maybe what we have to have is like maybe a status together with the user ID in the database, in the main database.
Hmm.
So like we have a user ID and we say like pending, right?
Hmm.
So the first check is to that in-memory database, and
Hmm.
if it exists, even
Hmm.
in a pending state, if the record exists, right away
Hmm.
return a failed response. Um, um, if if it doesn't exist, we write one with a pending status. And then we have
Hmm.
to make sure that we have count available. So we make a
Hmm.
request to the counter. And if we have available, we decrement and then write succeeded into the database and we return a success response.
Hmm.
Otherwise, we go back to the database and just write failed. Um, and a failed status. So yeah, it seems like we would have to have two checks to the main database and then one to
Hmm.
the counter.
Cool, awesome. Yeah, I think yeah, this will work. That's a pretty good design. Like you covered a lot of things. So now let's say like this is a design which you have. What do you think could be what you will do in terms of making it operational in terms of operational excellence? Like what alerting, monitoring you would
Right.
like
So
to
we need to
apply
have
here?
like
Mhm.
right. So we need to have a monitoring service, and I guess we can just monitor basically all levels of the service. Like meaning we can
Hmm.
check throughput, right? We can have
Mhm.
like a
Mhm.
monitoring service that checks throughput to the database
Mhm.
to the main database and make sure that if it goes down,
Hmm.
below what we expect, we have an alert. And the same thing with the counter is basically on all levels we check
Hmm.
throughput. We also check response time.
Mhm.
Um, we check what else? We can also check like memory utilization on the
Ah.
different distributed counter instances or on the main database as well. We can have like memory utilization measurements and alerts. Um, but yeah, I think those are pretty much the main. We could also
Mhm.
like another thing we can monitor is like response error responses. If let's say like an
Mhm.
error responses go up, then maybe
Mhm.
we can see which is there a specific user that keeps on making requests and
Hmm.
maybe sort of block that user at the API
Good point.
gateway
Yeah,
level or like an
that's a
earlier
good point.
level or something.
Yeah.
Yeah.
Cool. One last question. You talked about API gateway rate limiting. What kind of rate limiting this would be?
Um, what kind of rate limiting? Um, that's a good question because over here, um, uh, that's a good question. When I was thinking about rate limiting, I was thinking of like for like that this API gateway would sit
Mhm.
in front of like all of our different services. Like I'm assuming like
Mhm.
this app has more than just a burger giveaway service.
Mhm.
So, but the truth is, you make a good point that rate limiting, maybe we can have like a limit of one
Mm-hmm.
on this specific, endpoint, on the burger
Mm-hmm.
giveaway endpoint. But I don't think we would want to have a rate limit of one, because
Mm.
what happens if for some reason we have an error
Lots of
response?
requests, yeah. Yeah.
Yeah, so but we would have, so rate limiting would be, I'm not sure what you mean by like what type of rate limiting, but what I'm imagining is like some configuration where by where where we have a specific configuration per
Mm-hmm.
endpoint of like
Mm-hmm.
how many requests we can have like per minute or per hour or per something. So like we can
Ah,
have
makes
some
sense.
sort of algorithm that,
Yeah, so that
and
like
this
your rest of the things won't be like overwhelmed. Yeah, makes sense.
exactly, yeah, yeah, that's what I mean.
Circuit, yeah, so it's kind of circuit breaker. Okay, got it.
Yes.
Cool. Yeah, that's such a solid design. Yeah. Yeah. Let's move to the feedback part of it. Like, yeah, I think like
Okay.
most of the things were like really good. Like you really did well. In functional requirement, non-functional requirement. I think like one thing like do you have any framework in mind? One thing I think is like you missed quite a few details like you missed like estimation part overall, like you did not talk about estimations at all. Yeah, and
Estimation in
then
terms of like storage. Um,
yeah, it could be like storage estimations. Yeah, because like here that storage estimation was important to make a decision of
right.
like whether your in-memory database is enough, whether you need caching or not. Like so, you were using cache and things which were not relevant to this design. Though you were able to correct it and understand and get that feedback, that's a good positive point. But like it doesn't look good. Like it's expected that a senior engineer can ask or gather all the numbers which are important for design, and storage estimation is one of them.
Hmm.
So yeah, to like basically like you have good structure, right? So you talk about functional requirements, you talk about non-functional requirements, so you can have third section saying that estimations, and there you can do the estimation about QPS and storage and those
Hmm.
things. So that
Hmm.
like you don't skip it, like add it to the your format, like you already have a format, right? So
Right.
add that one step to your format, and that would be good. I'm not saying like it's not a big deal, but like these are the small things. Like I want to feedback to be on like improvement side. I don't want
Hmm.
to give like everything is good and just go. Like I know like most of the things are good. Your 90% of your 90% of things are good. I just want to focus on 10% so that like there's no any stone unturned, so that you can work on it. So yeah,
Right.
so there is no question on your skills or your preparation. I'm just talking about like you could have also introduce you can introduce estimation as one section, and
Hmm.
you won't miss such critical data, and then there won't be back and forth in your design decisions when you are deciding on the storage, applying caching, applying database. So yeah.
Hmm. Makes sense. Makes sense.
Cool. Yeah, so basically, I would also suggest you to add one more section in your
Hmm.
after like estimations and API design, right?
Oh,
So basically,
API
here it
design.
was here it was a single API, but let's say like if there is a question like Uber system or something, right? So there would be multiple APIs, user-facing APIs, right?
Right.
And it gives you that a feeling signal that you are thinking about abstraction first, and then like basically that's how you usually do the coding also, right? You talk about the interfaces and then you go and implement those interfaces. So similarly, like you talk about the contacts of your service, and then you go and come up with a high-level diagram for implementing those service. So
Makes sense. Yep. Makes sense.
yeah, I'm not saying like a miss, like skipping it would be a big issue, but like just adding it will give you the it will make you whole around sound like a very structured experienced engineer.
Hmm.
So yeah, that's why adding these two sections would be could help you to bring some structure into your thoughts, or like or it's not about like thoughts, it's about like how interviewer perceive your design. So it gives him a structure, like okay, fine. Can they talk about estimates? Can they talks about APIs? And now he is going to implement those APIs using different services.
I
So
see. So
yeah.
you would suggest talking about the API before the high level design. Is that correct?
Yes, yes.
Mhm.
So just after the estimations, non just no, you can have like this section functional, non-functional, then estimation section, and then the
Mhm.
API design section, and talk about the APIs. We can talk about like user-facing APIs, or let's say in some cases there would be some background APIs which are not
Mhm.
user-facing, but like you might want to talk about them. You can talk about them so that you don't miss on any critical thing. And then you did what you did was anyway good. Like there is no scope of improvement, at least in your design process. Only one small thing which you can additionally do is like you do talk about you do reason about your design choices, and you do talk about them, and but the interview is one hour interview. If you have time, maybe you can talk about like you can explicitly talk about, okay, this is a trade-off, and these are the two choices, this is a pro and this is a con. You can even write that down so that like it gives a clear signal that you identified a trade-off and you talked about pros and cons. Doing verbally is also fine, but like if you do it, like if you write it down, it gives easy to note. It makes it easy to note down for interviewer also that, okay, candidate did a trade-off analysis and he or she did come up with a pros
Right.
and cons, and then
So
make a
in this
choice.
design,
Mhm.
did you see like a trade-off discussion?
Oh, you
Uh,
already did. Yeah, you did talk about like you did talk about like pessimistic locking, optimistic locking, worsening. You
right.
talk about different solutions, and
Mhm.
you did make a right choice. So yeah, I'm not saying you miss
Oh,
out
but
on
you
it.
mean like to actually write it down? Okay, cool.
Yeah, I mean
That's a
like
good
if you write
suggestion.
it down, and so it gives like clear indication that you did identify that trade-off,
Right.
and like, it would be easy for interviewer also to take notes. And if he's a new interviewer, he might miss this even if you're verbally
Mhm.
saying that.
Right.
So just be on 100% from your side, you give that signal. Maybe
Mhm.
do it for one of the trade-off, not for everything, but yeah.
Right. I see. Got it. That makes sense. That makes sense.
Yeah, and I also like your style of like coming up with high level problems and then keeping them parked for later. That
Mhm.
also shows that you just want to complete your design first, and then go into the individual components. That shows like you have worked on. That gives a signal that you have worked on such things where there are a lot of things,
Mhm.
and you goes in implementation details later and firstly come up with the different components. So yeah, keep doing that. That's a good thing you're doing. And yeah, only do I had only this feedback.
Mhm.
I will have I will write paste my detailed notes into the feedback.
Mhm.
um yeah, but
Okay, just one question I had is about like the service discovery or like the like zookeeper. So I noticed you didn't want to go too much into that. Do you think that this was a good strategy for like how to balance the distributed counter load?
yeah, that would have been I in my opinion, it would have been an overkill. You could
Mhm.
have just come up with like some consistent hashing algorithms which hash your user IDs into some numbers, and then you can take like and then from that number you can come go to one of the counters. Even that would have been like that would, because like having additional zookeeper, and I would add one more latency hop. So here every service can just come up with like hash that user ID, know the hashing algorithms that can hash user ID and come up with some number which can go to the counter. And to the problem of you, like some counters might be finished early, but like statistically hashing algorithms are expected to be uniformly distributed. So
I see.
yeah, having like that situation happening is statistically rare, and you
Mhm.
can rely on stats. So
Got
yeah,
it. Okay, that makes sense.
it's not like um some positive or negative. Yeah, but I personally don't expect like one particular solution to be true.
Mhm.
But like yeah, I just want I just expect candidate to know reasoning behind their choices, and
Right.
you're doing fine. You're doing good at that. So yeah, having Zoo queries also works. But yeah,
Got it.
there could be an easier solution here.
Got it. That makes sense. That makes sense. So you think for L5 at Google, this would be a higher decision, this interview?
Yeah. This would be a high edition.
Okay, awesome. All right, I really appreciate it. This was good feedback and good question. So appreciate it.
Cool. Cool, awesome. All the best. Yeah, the only one additional thing which I talk to every candidate who is going for Google is
Mhm.
that your coding interviews also has like coding interviewer also decides your level, unlike Meta or something like Uber, where coding interview
Mhm.
does not decide the level, but Google coding interview also decide the level. So don't
Mm.
go with the approach of just solving the problem. Do consider about asking questions like will entire graph will fit in memory, or do I need to worry about it? And once you are
I
done with
see.
the code or something, to talk about testing, validating input, making the code more modular, or don't even shy away from talking about parallelizing your approach. So yeah, so
Mhm.
I'm just saying like these additional things. So like Google coding will also decide the level. So do give signals that you are experienced engineer, and you are not just one who just come and write a code.
Got it. Makes sense. Okay, that's a good
Cool,
point.
awesome. Yeah, all the best. I'm really hopeful you will get through at least Uber and Google. So yeah.
Okay, awesome. Thank you so much.
Yeah, I think yeah, you need to write a feedback after this. So yeah,
Yeah, I will. Yeah, I was very satisfied, so I'm gonna give the good feedback.
cool, awesome. Thank you. Bye bye.
Okay, bye.